Dear ladies and gentlemen, welcome to the lecture on risk assessment for technical products in the European Union. My name is Janez Furlan, and I'm international product safety consultant. I have worked in these fields for over 25 years now, and I'm glad to be explaining the core principles of risk assessment in the EU. The lecture will be divided into 3 blocks. Each block has several key outtakes, and I will try my best to explain it in a simple and effective manner. So if we go first to the first block, we will start with the general principles and best practices for risk assessment of technical products. We will try to learn why risk assessment is needed at all. Why do we see unsafe products on the market? How the risk assessment process should be done by the manufacturers. Then I will explain the basics of risk assessment, the methodology, the principles, and at the end, I will also have a transition into the how to tackle the risks, which measures can be taken by the manufacturers, and also I will guide you through the basic guidelines and standards that are developed for this purpose. Why risk assessment is needed? So there are several reasons for that, but let me start first with the number of the products that have been recalled last year in 2024 at the territory of European Union. The number is significantly rising. We have seen a great increase over the last few years because of the efforts of the authorities to tackle the dangerous products. And this is one of the reasons that risk assessment should be done well ahead in the design phase, as we will see, in order to, first of all, protect the consumers, prevent them from injuries, then to meet regulatory requirements across markets so that we, or the economic operators, manufacturers, are even able to sell their products. And this is also a good tool to protect your businesses and reduce financial and reputational risks. Last but not least, risk assessment can also be used for cost reduction and quality improvement because it's a tool that identifies some weaknesses in design at the early stage, and we can, as manufacturers, can address them at low cost rather than doing some corrective measures and improvisation later on. So there are several reasons for this, and if I may just make a note on one of the recent recall on hair dryers, which we will discuss today. In 2023, a manufacturer of hair dryers had to recall 50,000 units because it turned out that they cause fire hazards, and several accidents were reported. It was discovered that there was a design flaw, and all these products have to be taken out from the market, which resulted in significant costs of 2.5 million in euros, and actually some of the homes were also prevented from fires. Why do unsafe products actually appear on the market? What are the root causes? Not going into much of the detail, but most of the unsafe products are resulted because of the price competition on the market, where manufacturers are trying to do cost-effective production either this is done well in the design phase, or they try to improvise in the production when the serial production starts or takes off. And further on in production, even if the production seems to be fairly stable, unsafe products may be found on the product due to lack of quality control, or later on in the supply chain due to damages during the transport and storage. It is very rarely that the products can be caused by the unskilled workforce. Usually there should be a deeper systematic reason for this. And the inspectors will not be very happy if somebody says these products on the market were found due to unskilled labor force. They will not be satisfied with blaming specific workers. One of the very common, let's say, examples on this price competition resulting in unsafe products is from the toy sector, where, for example, toys that are operated by button batteries or have some functionalities supported by button batteries are not well designed, and the children very easily can access these button batteries, swallowing them, which shouldn't be possible. The battery should be safely stored in compartment within the toy, and there are a number of toys being recalled for this reason. But how do we know where is the limit where we can say that the product is safe or unsafe? The answer lies in the common European methodology, which differs from sector to sector, but in general is always the same. So today I will explain it for the low voltage equipment, where risk assessment and threshold values are explained well in the Senelec Guide 32. What you can see is maybe a boring workflow, but in the next slides I will explain more in details how the risk assessment actually should take place from the manufacturer's point of view, so in the design phase. We need to know that risk assessment has some steps which will systematically address the hazards which may be identified with the product itself. And then we have some common methodology how to evaluate whether these hazards can materialize in an unfavorable situation like injury of the user, or fire in the home, or environmental damage. And then at the end of such evaluation, we will find out where do we know that we have done enough in the risk mitigation or risk reduction, as we say, phase, and stop with our efforts and say, okay, our product is safe enough, we can place it on the market. At this stage, it is well noted that there is no such thing as a 100% safe product. Each product has some residual risks, and these residual risks should be communicated with the user either through the warnings or through the instruction manual. However, this is the last step, the administrative warnings. Before that, we should do as much as possible in the design phase to technically design out or reduce the risks associated with the product. When we are doing the risk assessment, we clearly need first to identify the product, its intended use and limitations. This is very important because some of the products that are lookalike maybe are not intended for the same consumer group. For example, kitchen mixer, as we can see it in the picture, this can be used either in the regular homes for the average consumer, but we may also have some commercial mixers which may be bigger, which may be faster, stronger, and the difference is that the two types of the mixers have different standards. They have different requirements because one is dedicated for the average consumer and the second one is for the professional users. We also need to take into account all the life cycles for the product. The risk assessment should take into account things like assembly of the products, especially if it's done by a consumer, its maintenance, repairs, and also disassembly or so-called the end of life cycle, which is usually connected well with the environmental issues. Last but not least, the packaging of the product should also be included in any risk assessment, especially for toys. This is a well-known risk. When we are speaking about products life cycle considerations, we need to have in mind that each type of product has different specifics. Some would need more, let's say, efforts in maintenance, in cleaning, in disposal, while some are actually very simple to use, don't need anything like this. And of course, the risk assessment is very short for very simple products. But for example, lithium-ion battery operated products, which are recently very common to find on the market, are one such product that really needs to take into account at least users face a risk. For example, changing the habits when charging the battery operated products. We all know that some unfavorable things can happen if the products are overcharged or they are keeping charging for too long. Also, there are issues with let's say, with the disposal of the lithium battery. And for this reason, the manufacturer has to do all the efforts that as much as possible, he designs out any kind of either safety or environmental issues that are related to such product. So we say that risk assessment actually starts with the product identification, and then regarding to its nature, we can start with the identification of the hazards. Typically, products are grouped in the hazard groups. Electrical hazard group is associated with electrically powered products. Mechanical hazard groups, wherever there is some moving parts, is always relevant. Thermal hazards are present where there is some heat powered or presented with the product. For example, kitchen cooking appliances. Chemical hazards are almost always relevant and present with toxic materials, or some sort of reactions could take place when using the products, ergonomic issues, radiation, and so on. The list of the hazards are usually available in the harmonized standards for the risk assessment. So somebody already did a checklist, and it is up to the economic operator, in particular for the manufacturers, to use such useful checklists in order not to forget or not to overlook certain risk. For example, a manufacturer of a hair dryer cannot just say that the fire started or the fire can be caused by the hair dryers, because he was not thinking about that the plastic could be engulfed into the flames, because he was not using the fire resistant materials. So here is one such very useful checklist from the Annex C of Senelec Guide 32. Is a spreadsheet where everything is already done, and it is well advised for the manufacturers to use such checklists. After we identify the hazard, which is a potential source of harm, we need to see how hazard can develop into the unfavorable outcome. That means either in injury or in environmental harm or anything else. We call this mechanism an injury mechanism. So from hazard to hazardous events and the damage, the unfavorable situation. Sometimes this injury mechanism is a chain of events. Sometimes one situation leads into another one, and at the end we have some very unfavorable situation. How do we do this? We need to take again the standard and try to use the checklist as previously seen, or try to develop possible scenarios that can happen with specific situation. The professionals know that specific type of products have specific hazards. Not every product has all the possible hazards, and they are actually an intrinsic property. They are associated with their nature. What we need to do as manufacturer is that we need to properly address and properly identify all the hazards associated with this product. We shouldn't skip a single one because unless there is no hazard associated, there is no risk, of course. But everything else should be addressed, and usually it is also documented in the documentation of the risk assessment. When we are doing the evaluation of possible risks, we also need to take into account the consumer group that will be using the products. In particular, when it comes to the consumers, we have to take a look at the vulnerable consumer groups, in particular small children or elderly people or handicapped people. We also need to have a clear understanding whether the product is intended to professional consumer users or is it for the average consumer who are supposed to use the product with no significant effort, and their ability to use the product is somehow expected. If this is not the case, we of course need to address these issues with risk assessment, with proper design of the product, and of course also with the later on with the list of the residual risks usually contained in instructions for use. We also need to take the differences in consumers' cultural background. Maybe what is risky in European Union may not be even treated as a risk in Africa or Asia. Therefore, we of course have to know about the final target markets. This is also one thing that we have to clearly put into the very initial assessment. of intended use. In this slide, I would like to point out the difference between the hazard and risk. There is a big big difference, while many times this is often understood as the same thing, which is not. Hazard is only an intrinsic property or condition with the potential to cause harm, regardless of probability that it will happen. That means that hazards exist even if nobody is exposed to it. Yeah. However, risk is a combination of the probability that the harm will actually happen and the severity of such harm. Jointly set in expression, mathematical expression, we can say that risk equals a combination of probability and severity, or multiplication of probability and severity factor associated with specific risky situation will define the level of risk. This difference have to be clearly in mind, especially when the manufacturers has doubt or doesn't really want to admit that specific situation theoretically or practically can happen. That means every risk needs to be addressed, even if the probability that this will materialize in harm is very small. So, in short, no shortcuts in risk assessment is allowed. In order to better understand the difference between the hazard and risk, let's have a look at these two pictures. On the left, there is a guy who is trying to balance above the, let's say, thick blanket. And on the right side, we have an airplane, which is probably, or it looks like is in trouble because one of the motors seems to be broken or not working well. Now let's have a question. Which of the two situations is more risky? Having in mind that probability multiplied by severity defines the risk level. So on the left, we have, as you can see, high probability that this guy will lose the balance and fall onto the blanket. However, the height of the fall is very low, and even if he falls, he will not probably hurt himself so much. So severity is very low. While on the right side, we have completely different situation where probability that it will the motor will stop working is very low on the airplane. Technically, it's very low, but severity of the consequences could be very high because the airplane may land hardly or maybe even fall down from high altitude, causing fatal risk. So generally, when we multiply the two parameters, we can see now that the risk is nearly the same. It may sound strange, but it is not. In the European methodologies, we have standards that are used to determine the risk level. What you can see now on the right side is so-called risk graph or risk nomogram used for low voltage electrical equipment, and it's taken out from the guide 32 that Senelec has prepared for the manufacturers of the low voltage equipment. Kindly note that there are other sectoral standards, for example, ISO 12100 for machinery, ISO 14971 for medical devices, and others which cover other type of technical products. But if we keep with the low voltage equipment, we can see in this nomogram that by properly selecting factors S as severity, F as frequency of exposure, and P as probability that it will actually occur, this selection of factors will lead to the classification into one of the 5 risk levels, risk indexes. The highest risk level is 5, the lowest is 1, and it's green. So whenever we are going into the red direction, it is an alarm, it is an alert for us, and we need to think how to lower the risk, how to mitigate these risks. When we are doing the severity classification, this is factor S, so severity of consequences, S. We, of course, need to take into account what can actually happen to one or more persons or animals, or what can happen to property, what can happen to house where it is used. And in few of the examples that I have listed here, we can see the difference. For example, what can happen with electric coffee maker if hot water spills, causing second-degree burns on hand and arm. It means that this is not a lethal injury. Nobody will die because of it, but of course, somebody will have some consequences, probably short term, some medical attention possibly, but that's all. While with the faulty space heater, the difference is that it can result in a lethal situation where the property can be engulfed in fire, and of course we can have multiple deaths in such situation in the building. What is usually quite a challenge is not the determination of severity of the risk, but rather the estimation of probability of occurrence that such hazardous event will actually materialize in unfavorable consequences. We have several methods actually to do this. Maybe I will not go into details, but some of the methods can be computational. That means it can be calculated, while some of the other methods rather use quantitative assessment. And this quantitative assessment is also used in the Senela Guide 32, where on the right side, now you can see the shadow rectangle is a section that defines the probability that occurrence of hazardous events will actually take place. What are the factors that are affecting probability is foremost the frequency of exposure, or factor F. F1 stands for rare exposure, F2 stands for often to permanent exposure. Then we need to, of course, take into account the level, the group, the consumer group, where these are professional, experienced people using the product. Possibility to avoid, or factor P here, P1, P2, as you can see. P1 stands for it's very easy to avoid the hazard. P2 is not possible to avoid. It's not possible to quickly react to the hazardous event. We also need to take into account the maintenance issues and the deterioration that equipment is exposed to, and after sometimes there can be some single fault occurring in the operation of appliances, when we need to take into account also this. Not every product that was found on the market and is defected, maybe malfunctioning, doesn't necessarily say that the complete series of products is also defective. This will be later explained how we do this, but it has to be well designed so that the, let's say, very vital components do not stop working in the foreseeable lifetime of the product. And if they do, they need to be replaced very easily. So the question arises, when is the product assumed safe enough? So in graph for risk estimation, we will not find the answer, but we will find the answer at the very last sentence of this guideline. If the risk is mitigated with the solutions from the harmonized standards, then we can say that the product has reached a minimum level, or so-called the threshold level required by the European legislation. When we are talking about mitigation of risk or controlling the risk, we need to have in mind that we have three types of possible risk reduction measures. And the first one is the first step. It shouldn't be skipped. It's called inherently safe design, where we can design out the hazard sometimes so that they are not present at all simply by the inherently safe design of a product. If this is not possible for the sake of the functionality of the product, we will probably opt for the second possible technical approach, which is safeguarding. We are using guards and safety appliances to control the areas which can be causing some risks. For example, we will guard the moving parts or guard the very hot parts. We will implement sensors, switches, and so on, other safety appliances to control access of the user to the dangerous zones. Last but not least, the last step is information for use, which can only be applied when the first and the second options are exhausted. So when we are left with no more technical safety measures, we can only then inform the users via warnings or instructions for user trainings about the residual risks. Typically, these are warning list labels in forms of the pictograms, very standardized warnings, and so on. To summarize what risk assessment actually is that we, by identifying the associated risks with the product and application of the technical and administrative measures, we are reducing the risks to the level of tolerability. So at some point, we can say we have done enough for the product, and we can say it's safe enough for the consumers to be used, and we can dispatch them onto the market. It's only the residual risk that needs still to be addressed, usually via the instructions for use. Or if we have a look back at the process itself, we see that if the risks associated with the product are not tolerable, we need to apply these three-step methods to finally end up at the level of acceptable or tolerable risk. This is just another presentation of the tolerability of risk. As I said very early at the presentation, there is no such thing as 100% safe product, and we need to contain the residual risks to the user. We mentioned already now several times that the acceptability of risk is coded into the standards. In Europe, they are called harmonized standards. Some standards are developed for entire product group or specifically for specific product type. For example, for the kitchen machine, hair dryer, there is a product standard for this. But many times products are very unique, one-off, innovative. In such cases, we don't have the ability to use the product standards, but rather we use generic standards which cover one type of hazard or hazard group or safety concern. Now, these standards are developed for particular sectors in technical committees and with stakeholders' consensus, and they usually can be seen as or listed as the product standards or generic standards. Before moving into the standardization, let me also explain the importance of the objective assessment of the severity of injury. And there are several factors that contribute to this severity. One specifically would be in which body part somebody can get hurt, because eyes are more sensitive than, for example, body or legs or lower limbs. Also, we need to have in mind the magnitude of hazard, the duration of hazard, and so on, and of course typically whether the consumer group contains also the vulnerable groups like children. It is the severity of injury would be much higher. Children cannot help themselves in, let's say, helping themselves if they are injured. And with the previous slides, we have somehow finished the first block of this presentation, which was dedicated to the general principles, and I have addressed in particular how are the major steps that need to be taken from the manufacturer to dispatch only safe products on the market.